Alrighty, for this problem we're asked to evaluate the integral from 0 to 1 of the following vector valued function. So 2t, 4t, and negative cosine 3t, and then dt. Okay, so to do this we have to basically integrate using the same bounds each component individually. So what we're going to have is integral from 0 to 1 of 2t dt, integral from 0 to 1 of 4t dt, and lastly, integral from 0 to 1 of negative cosine 3t dt. Okay, so for the first two, those are going to be pretty simple. And then for this last one, we'll have to do a u substitution. Okay, so I'm just going to make the u be our 3t. Okay, and therefore du is equal to 3 dt. And now what I like to do is get the dt by itself. So I'll divide by 3 on both sides. And the reason for doing this is that right now we have something that automatically subs in for 3t because we're going to put a u in this spot, right? And now I just want to substitute something directly in for dt. So now we just solved that dt is equal to du over 3. Okay, so you'll see as we go along how this is going to work. So for the first couple components, this is what's going to happen. So we just integrate, so t squared, and that's as t is evaluated from 0 to 1, comma, and then we have a 2t squared, and again t is valued from 0 to 1. And then here we have a negative, and then we have the integral, and what I do is whenever I kind of like substitute in the u's, in the u variables, then I remove the bounds because technically that's not mathematically correct if you keep the same bounds there for t and pretend that they're for u. So anyways, I just don't do it. So I just remove those. And this is what we're going to write. So cosine, I have that negative sign out here. I just brought it outside. Cosine and 3t is now a u. So that's a u here. And dt, we can sub in du over 3. So du over 3. Okay? This is kind of separate, sort of. Okay. And then we have the arrow sign, the closed arrow bracket. All right. So now, if we continue, we get a 1 squared minus 0 squared. Pretty uneventful there. 2 times 1 squared minus 2 times 0 squared, which is just going to end up being 0. And then this last one here, that's the messiest one. So then I'm just going to bring this 1 over 3 outside, just because it's a constant, right? So I'm going to bring that out. And then we have the integral of cosine u du, which is pretty simple to integrate, right? So I'm going to continue one more line down here, and then I'll probably have to go on to a new slide. So here we just have a 1, and then here we have a 2, 1, comma, 2, comma, negative 1 over 3, and this is actually just going to be a sine of u, right? So now I'll move on to the next slide, and remember that u is equal to 3t, okay? Alright, so at this point we have 1, comma, 2, negative 1 over 3 sine u. Alright, so this is going to equal 1, comma, 2, comma, negative 1 over 3 sine 3t. I'm going to replace the t's, and when I do, I'm going to replace the bounds. So that's 0 to 1. Okay, so there was just kind of, the bounds took a break, or the limits, like the 0 to 1. The 0 and 1 took a break when we were subbing in the u's. Okay, so anyways, we're just going to continue from here and evaluate. So we have a 1, comma, 2, comma, negative 1 over 3. And then we have a sine 3 times 1. And then minus a negative 1 over 3. And then we have a sine 0. Okay? So that's going to be the third component there. So we have our 1 and 2 still there. They're sitting there. And then we have a negative 1 over 3 sine 3. And sine of 0 is just going to be a 0. So that just goes away. And this is what we're left with. So this is the answer. And you can also rewrite it, just because I have extra space down here that I can use. Negative sine 3 over 3. Okay? So this is our answer for the integral that we were given to evaluate.